Guys, in this video I'm gonna be trying to make something called biodiesel, and the name is kind of self-explanatory. It's a diesel made, a kind of diesel. It's not really that much the same to diesel, but you could put it in your engine or well, use it as your fuel if you have a diesel engine. And well, really it's just diesel that's made from natural resources, right? So the problem with a real fuel like, you know, gasoline and diesel is, well, there's two main problems. First off, well, once you've used them all, you know, there's really none left. So eventually we will have to switch to things that are renewable. And the second big problem is, well, the CO2, right? When you burn those fuels, CO2 is gonna get released in the air and a lot of other toxic stuff. Now, this problem, you might think it doesn't really go away with biodiesel, because if you burn it, it still makes CO2. But you know, the plant from which you get that carbon which you're gonna burn, that has to have absorbed the same amount, or well, rather more CO2 out of the air, right? So that's good, and it's renewable, because I mean, plants can grow all over again until the sun dies off. Until we can't get any more energy from the outside, we could do this virtually forever, right? So the only three things you need really to make this is oil and some alcohol. I literally found this at home, right? Damn, this is bright on the camera. I actually just found it in some cabinets. I don't know why we had it at home. And I thought, what could I do with this ethanol that's pretty pure? And yeah, that's what came to mind. Well, what you need is some kind of oil, this ethanol, or whatever alcohol. The smaller the better. Alcohol is the second smallest alcohol. Even better and smaller would be methanol, but I don't have that at home, right? I'd have to buy it, and I hate buying stuff. And what you need is sodium hydroxide, which is then the kind of catalyst that converts it. Well, you know, I'll talk about the details later. And yeah, but if you do this at home, please do be careful, because sodium hydroxide is really toxic. Well, rather caustic. So let's get into the explanation. So the two main components that are really reacting with each other are the alcohol and the fat, or the oil, right? So what the fat actually is chemically are triglycerides, right? And each of them has one long fatty acid chain and a glycerol backbone, as we say, right? And in the reaction between the alcohol and the fat, catalyzed by the sodium hydroxide, of course, the glycerol backbone is replaced by the alcohol. This then creates biodiesel, or more chemically a fatty acid ester, which then burns way better than the normal oil. I mean, normal oil, it does kind of burn, right? Like a candle. If you take up a piece of like paper or whatever and soak it up with some oil, it will kind of burn, I guess, right? But not as well as those fatty acid esters or biodiesel. So I'm in the lab now, and the thing is, to make biodiesel, the mix really needs to be stirred very much, right? So for an hour at least, it should be kept warm at say 50 C and stirred. I don't yet quite know how to keep it warm, but I have built something that should stir it. Look at this crap. So yeah, the actual piece of junk that you see right here is what I came up with. Wait, let me show you really quickly. The thing is, I have to hold the motor too. Can I get on with my feet? This is not as easy as it may look. Yes. Okay. So, as you might see, as you probably see, it's a motor here, and there's a little piece of wood attached to the bottom, right? Absolutely horrible, but I mean, it's better than nothing, right? So now I put it all together, the stirrer and well, a self-made heater, okay? So I used three, I think AAA batteries and put them in series, because I tested it and I had a little thin strip of wire. Look, I have still all the wire left. This is from my transformer. Watch the video right now, or well, after this video. I thought it was pretty cool. Enough ads for now. Anyway, I used a little strip of this wire. I just literally found it in there, and I tested it with 2.5 volts from this power supply, it reached 5 amps, right? And with 3 volts, in theory, it could reach a bit more, but I'm unsure how many amps these batteries really can do. Because, I mean, 2.5 amps per battery is, I mean, that's kind of much. But really, I don't know a lot about batteries, so I really can't say. But I did test it, and at the contact, at least, it got very hot. I'm not sure about the rest of the wire. It makes sense that it gets hot at the contacts because that's where the majority of the resistance will be, right? Right. So I think I will spray on a little bit of water on there, such that I can, well, you know, that it cools down. By the way, I ripped my glove here a bit, but I just used some tape to fix it because, well, why waste the plastic? Now, I guess I'm all settled. I'm done. I guess I will start mixing everything. So I added around 100 milliliters of ethanol and 2 grams of sodium hydroxide. Now I'm stirring it. The sodium hydroxide is really not dissolving that well. Now the thing is, I wanted to add 2 grams of sodium hydroxide, but the scale was acting up again. Well, it's not that the scale is bad per se, but it's not just made for this. Like, it's a food scale. It's like great when at higher weights, you know, but not in the weight range of like anything from 0 to 5 grams. By the way, yes, that is a glue stick with which I'm mixing it. I mean, usually I take one of my screwdrivers, right? But, you know, screwdrivers are made of, well, steel, right? And they really aren't great against sodium hydroxide. I hope this is gonna survive, but it looks great. Yeah, this appears to be working really, really well. I put everything now again, and the heater, I activated that too. But I don't feel any heat, to be honest, coming off that. Well, oh yeah, there it is. Hell yes. I actually am pretty happy. And you can see, that the mixture has cleared up very much now too. Damn, that's great. That really is great. Oh, well, you can see that the wood is too far on this side. I think I will try moving it by putting the motor a little bit to this side. So when I woke up tomorrow morning, I saw that the motor wasn't really spinning anymore. And, you know, then what I did was what I always did, right? I had to do it that once already, right? Because when this jiggles around like that, I mean, that's the not so good thing about using wire. If this jiggles around like that, then it's gonna slightly, with every move, some material from the insulator away, right? And sometime it's gonna take long, right? But they are eventually gonna short. And that's what I did tomorrow morning too, when I saw that really the motor wasn't spinning anymore, but it still wasn't spinning. By the way, the voltage was at 0.6 volts. Now I turned it up to 0.9. So either the motor has got a problem, which I don't think it is, or the viscosity has risen, which may indicate a chemical reaction. I really don't know if this is a good indicator that the biodiesel right here is being made, but I mean, it could be. So after 24 hours of running the experiment, I decided to stop it now, because it has to be finished, right? And now I'm gonna put it in the oven at, say, 50 degrees Celsius for like another hour or two to just, well, I think it is gonna help with the reaction, even though it's not gonna be stirred. It's not gonna be great, but better than nothing. And also with some ChatGPT research, to be honest, I mean, I was quite lazy. Right now, I found out, I guess you can heat it to make the separation better. And I mean, I'm gonna try it. If that doesn't work, I'm gonna cool it a lot to see if that works better. So yeah, right now what we should get then is a dense glycerol layer and maybe like whatever side products remain at the bottom and the biodiesel at the top, because it's supposed to be pretty light. So let me put this in the oven now. So I decided that maybe the oven isn't the best thing, right? Because I can't really stir the mix, and yes, I do want to really stir that mix more, because, well, I'm really skeptical if the virtually unheated method really works that well. So yeah, I'm gonna try to see which temperature this water is, if it's already warm enough. It should be somewhere from 50 C to Well, are you serious? I certainly do not believe that this water is almost minus 30 degrees. What? It doesn't matter if it's Fahrenheit or Celsius. I guess I will just have to use my finger. So I researched on how hot 50 degrees C actually is. So I could if this is 50 Celsius right now, I could put my finger in there for a few seconds until I get burns. So let's test it out. In theory, it should be a bit warmer than that, but I mean, it should be enough. It isn't really that precise, I guess. Oh, dang! That is hot enough. Okay, kind of boring. But anyway, I guess I will do this for around an hour now. But I guess it won't be that boring, right? Because, I mean, I have the internet to use, right? The heaven of instant gratification. So, by the way, these clouds are interesting. Oh wait, let me hold it like this. So I left the biodiesel to stand for another day, but what I expected or what should have happened is that a glycerol layer separates from the biodiesel, but that didn't happen. Maybe there was too much water in the mixture, which caused some soap to form, which made an emulsion, right? But I hope it shouldn't be too bad, so I have 2 pieces of paper right here folded in the same way, and now I'm gonna test the burning capabilities of 1 with just nothing as a control burn, 2 with just regular olive oil that I used, and 3 with biodiesel. And you might think that some ethanol that may be left in the mixture may kind of contaminate the results, right? Because itself burns pretty well, but I can smell it. It doesn't really smell like ethanol. It smells like oil, but kind of different, not quite the same. So here is the control group. It shouldn't burn really, this shouldn't be a very exciting result. Okay, but you can see, since I folded it twice, there isn't really a big, there isn't really a big fire. A little bit, there is, but yeah, now you can see it's starting to build up. Yeah, I can feel it's just a bit warm here. Oh, now it's getting warmer. Still, I can hold my hand like 10 centimeters away. So this is not great without anything. Ah, well, it is starting to increase. By the way, on camera, this looks more intense than in real life. In real life, the flame is more yellow than in the same camera. So yeah, not surprising very. You can see a bit of smoke coming off, although it is not a lot. Decent amount. I can also smell it if the wind pushes it in my face. So very expected this all. So for the control I used rapeseed oil. And now let me spread a little bit. I did use quite much in my opinion. So let's see how this burns. I expect a flame that's kind of, slower but more powerful in general, right? Because I mean the oil does combust too, although a bit slower and I guess, well, less powerful at the beginning. So with the oil you could see that the flame was stronger, but it took longer to develop and it also burned quite long. So here's the biodiesel. I used basically the same amount as with the oil. So let's see how that burns. Okay, that was actually really good. So what I'll try to do with it now is put some pure biodiesel on this spoon. It's been absolutely violated, as you might be able to see. It took most of its damage from my sodium hydroxide project. Okay, by the way, I'm holding my camera in between both of my knees, which is really hard. Harder than it looks maybe. But I'm gonna spread it on here. Now I'm really unsure if this will actually catch on fire, let alone burn well. Because, well, actual diesel doesn't really catch on fire like that too. But I mean, this isn't quite the same as actual diesel, right? I mean, its burning properties are just similar. Starting to smoke, okay. The spoon is getting burnt. Will it start on fire? Don't think it will. Oh, well, I am seeing some flames. Okay, what if I add a little piece of paper? Just a little. Okay, so let's add that to there. And by the way, diesel is not like gasoline, not at all, because it's more like wax, right, in candles. The wax itself doesn't really burn, or well, it does, but not with a steady flame. It needs like the... Wait, where's the lighter? Found it. Back to the analogy. It needs the kind of, thing that glows to supply constant heat such that it can evaporate, right? So let's light this on fire now. Okay. So, in retrospect, that worked pretty damn well. And yeah, look at this side-by-side comparison of biodiesel and the oil burning. You can clearly see what burns better, obviously. By the way, the thing with the spoon, it burned for 5 minutes straight. I got pretty bored. And anyway, during the video once, I said that biodiesel is not that similar to normal diesel chemically, and I want to apologize because I just realized that's extremely wrong, right? Because well, diesel is just a group of hydrocarbons, right, that are somewhere from 10 to 20 carbons, right? So rather long chained hydrocarbons. And the thing is, what it is with biodiesel is most fats are somewhere in the 10 to 20 carbon range. Like, for example, I think oleic acid, which is one of the most common monounsaturated fatty acids, I think it has 18 carbons, right? So those are all just pretty long chains. The fatty acid chain is basically the same as diesel, right? Just with an alcohol attached to one end. So I wanted to apologize for that, I guess, but that video was pretty cool. Make sure to watch my transformer video, or sodium hydroxide, or anyone else, you can choose. But don't you see those thumbnails here? Don't they look pretty cool? I don't know if this was the correct size. Bye.